Let's solve some basic forms of exponential equations. Exponential equations are very much important in real life. There are some real life situations such as the growth and decay, the compound interest, and the like, which uses the said concept. Right now, we are going to talk about solving these exponential equations, but we have these basic examples here. Let us proceed with items 1 to 4 and solve for the value of the variable which can make the equation true. To answer this kind of problem, you just need to determine, or what you call that, use these two properties. Number one, the properties of equality, definitely. That whatever you add to one side, you also do it on the other side, etc., etc. Subtraction, multiplication, division, everything will follow. And definitely, the second one, which is very important for this, is a property of equivalent exponents. The properties of equivalent exponents tells us that when the bases of exponentiations are just the same, it should also automatically mean that the exponents should also be equal. It will also be true the other way around. If the exponents are equal, let's say x squared is equal to 2 squared, if the exponents are equal, then definitely the basis should also be equal. But here, we're going to talk about the first situation. We're going to come up with the situation wherein the basis of our expressions should be the same for both sides of the equation. In number one, here, 3 is already in its simplest form. It's a prime number already. This would mean that we cannot express a 3 as a base of another number. But what we could do here is this 1 over 81. To do that, let's try to make this as an integer. So this could actually be written as 3 to the power of x plus 1 is equal to, as for this side here, we could actually express 81 as base of 3. And that is actually 1 over 81 is more or less 3 to the power of 4. It's not more or less. It's really 3 to the power of 4. Let's see. 3 times 3, 9. Times 3, 27. Times another 3, you will get 81. So 81 is actually 3 raised to the power of 4. But here, the expression is still fractional, while the other side is not anymore a fraction. This is the reason why we could use the reverse operation of the law of negative exponent. Even if it doesn't have a negative exponent, we could bring it up and we'll have here 3x plus 1 is equal to 3 to the power of negative 4. Again, it's the reverse operation because if we're going to bring it down, it will still become like this. Why? Again, our goal is to make sure that the basis of both sides of the equation will be the same, just like this, 3 and 3. And with the use of the property of equivalent exponents, this tells us that since the bases are the same for both sides of the equation, we can just simply remove the expression for the exponents and equate them. So that is why you will have here x plus 1 is equal to negative 4. For a while, let me rewrite it again, is equal to negative 4. And from this, it's just a simple linear equation. And then you just simply subtract both sides by 1, and you will have here the expression for the value of x, rather, negative 4 minus 1, you'll have here negative 5. So this is the value for x. If you would like to know if it's correct or not, you may you may substitute there, and you will have here this expression 3. Let's try if both sides will be the same. And let me increase or add some spaces here just for me to show the checking. Okay. I may not require checking later, but it's an important skill, as I have mentioned. So you have here 3 to the power of negative 5 plus 1 must be equal to question mark 1 over 81. Let's continue. So that's 3 to the power of negative 1, negative 5 plus 1 is negative 4. Is it still equal to 1 over 81. What is happening right now? 81. So you have here, bring it down using the law of negative exponent. So you have 1 over 3 to the power of 4. Is it equal to 1 over 81? The answer is yes. 1 over 81 is equal to, check mark, 1 over 81. Now that both sides of the equation are the same in our checking, this would mean that this is the solution for number 1. Again, checking may not be required, but then again, checking is an important skill. Let's proceed to item number 2. When you look at item number 2, 8 here may be expressed as an expression with a simpler base, such as 2, because 8 can become 2 to the power of 3 or 2 cubed. However, 1 here is 1. How do we reconcile this problem? Anyway, if we have an expression here which is equal to 1, we are actually very lucky because 1 here can be expressed as an expression with any base. Okay? So, because if you guys remember the law of zero exponent, 1 million raised to the power of 0 is 1. 1 half raised to the power of 0 is 1. Square root of 3 raised to the power of 0 is 1. 0.178 raised to the power of 0 is always equal to 1. So it's easier for us to solve this, and we can just simply use the expression here and make it 8 to the power of 0. Because if we do that, it's still equal to 1, and it now has the same base as the left-hand side of the equation. Now that they have the same bases, use the property of equivalent exponents, and we can share it here that 2x plus 2 is equal to 0. So subtract both sides by 2. You will get here the result of, for a while, you have 2x is equal to negative 2. And then divide both sides by 2 to cancel this out. Divide by 2. You will have here x is equal to negative of 1. This is the result when we try this one. But anyway, if you would like to express 8 as base 2 later, you can still also use 1 as base 2. But this is the simpler solution. Again, checking, substitute the value of x in the original. Okay, so you have 8, 2 times negative 1 plus 2. Is it equal to an expression equal to 1? The exponent here will become negative 2 plus 2, still question mark, equal to 1. Negative 2 plus 2 is 0. So you have 8 to the power of 0. Is it equal to 1? Again, an expression, exponent, number, variable, constant, raised to 0 will always be equal to 1. And then check mark, 1. This means that the answer for number 2 is also correct. Let's go to number 3. Number 3 here with bases 4 and 32. 4 cannot be expressed as base 32. Neither 32 can be expressed in a base 4. So what should we do here? Looking at the two expressions, we could actually express both of them as base 2. So we could write here 2 squared for 4 raised to the power of 5x is equal to 32 is actually 2 to the power of 5 raised to the power of x plus 5. Again, now we can express both of them at the same time. So once we do that, we just simply use here the power law. 2 power law means multiplication of exponents. You have 10x here. And then for the other side, you have equal to 2 to the power of, wait for a while. It's not 5x plus 5, okay? It's not 5x plus 5. Why? Because it should look like this. You have 5 times the quantity x plus 5. It should look like this, plus 5. Because the whole value of 32 is raised to the power of x plus 5. It's not like only the exponent 5 here. It should be like this anyway. So if we're going to do that, we need to distribute this 5 to both. Therefore, for the other side, it's still 10 to the power 2 to the power of 10x is equal to 2 to the power of 5x plus 25. Please do not forget to do that. And then here, since the bases are the same, use the property of equivalent exponents. And then you will have here 10x just equal to 5x plus 25. To solve, subtract 5x both sides. You will get here a value of 5x, sorry for that, 5x is equal to 25. And then divide 5 both sides, your x should be equal to 5. Okay? Before we could accept it as our final answer, again, checking will help us do the trick. Checking will use neither of these forms here, but it will actually use the original. So you have 4, you have 5, and then x is 5. Should be equal, question mark. So 32, you have 5 plus 5. Is 4 to the power of 25, sorry, is 4 to the power of 25 equal, question mark, to 32 to the power of 10? You may want to use your calculators, but yes, okay, it's power of 10. Let me try to compute it here for a while to see whether they are the same. Since it's very big, you may want to use your calculators for that. I'm going to give that to you, but I'm just going to use here the some processes for the loss of exponents to show whether they are the same. Okay, because if I will do this like this, it's very if we're going to give the value just like what happened in number one and number two, this will be very large. So if I'm going to express 2 as base 4 as base 2, so you have 2 times 25 here. I'm just going to show it this way. And 32 is 2 to the power of 5 times 10. So you have here 2 to the power of 50. And then you have on the other side 2 to the power of 50 as well. I'm not giving the value because it's too large. They are the same using just without giving the value, but just the loss of exponents. This would mean this is the correct answer. Okay, but you may want to check with your calculators if you want to. I have no problem with that. Let's proceed to number 4. For number 4, we have here 7 to the power of 4x, 7 to the power of 1 minus 2x, and another 7. So all of these terms are under 7. And 49 for the right hand side could also be expressed as base 7. So we could just use here base 7 for both sides. But for left-hand side, we can use the multiplication law because they are all of the terms here are multiplied. So you have 7 raised to the power of 4x plus 1 minus 2x plus the power of 7 here, which is also 1. That's for your left-hand side is equal to 7 squared for your right-hand side. Again, we just added all the exponents and considering it has exponent 1 here. So this would become 7 raised to the power of 4x minus 2x is 2x. And you have here plus 2, which is equal to 7 squared. Now that they have the same basis, you can have 2x plus 2 is equal to 2. And then subtract 2 both sides. This is 2 by the way. This is 2. Okay. You will get 2x is equal to 2 minus 2 is 0. Divide both sides by 2. X is as simply equal to 0. Let's use checking here. So substitute immediately. You may. So you have 4 times 0. Then 7, 1 minus 2 times 0. Another 7. Is it equal to 49? Let's see. Here, unlike number 3, which is too large here, we just simply get the value since the one side is just 49. Here you will have 7, 4 times 0 is 0. And then 7, 1 minus 2 times 0 is also 0. And another 7, question mark still, we're not yet done. So you have 49. 7 to the power of 0 is 1. Laws of exponents. 1 minus 0 is 7 to the power of 1 times 7 here. Is it 49? So 1 times 7 is 7 times 7. You'll have 49 equal to, check mark rather, 49. This means that the answer for 0 for number 4 is correct. So again, the concepts you need here, number 1, the laws of exponents. Number 2, the property of equivalent exponents. And number 3, the laws of exponents, so that you could simplify all of these numbers. Again, number 3, I'm giving it to you because it's too large. Okay? So use this video as you prepare for another assessment for chapter number 2 soon. Goodbye, everyone.